I'm Anil Kumar, and in this video we will investigate the relation between sine and cosine ratios. Question here is, determine three sets of angles A and B such that sine A equals to cosine B. Explain your strategy. It's three sets of angles. Okay. What we're trying to say here is, rather let us start exploring this and then we'll investigate and then figure out how do we get sine A equals to cos B. So what you can do is you can use your calculator and find the value of, let us say, sine of 10 degrees is equal to what, and then calculate what is cos of 80 degrees. Okay, so do this calculation. You could do sine of, let us say, 20 degrees and let us say cos of 70 degrees. Okay, let us do sine of 45 degrees and find what is cos of 45 degrees. Okay, let us use calculator and find these answers. So what we have here is sine of 10 degrees is equal to 0.1736. 4 decimal places is good enough. And let's say cos of 80 degrees is equals to 0.17, exactly same, right? So these two are actually equal. Okay, let's find what is sine of 20. Sine of 20 is 0.3420. And now cos of 70, okay, cos of 70 is again the same thing. So they are also equal, right? Let us say what is sine of 45 degrees. It is square root 2 over 2. Let me write this as square root 2 over 2. And cos of 45. Cos of 45 is equals to square root 2 over 2. Exactly the same answer. So in these three, we find that the value of sine of 10 is same as cos of 80. And sine of 20 is same as cos of 70. So can you figure out what is the relation and why is it so? Now let's look into this into greater details. Let's say we have a right triangle here. So I'm making a big one so that we understand and appreciate what exactly is going on. And let's say that's the right triangle. And let me say that the point A is here for us, right? And let's say this is angle A. If this is angle A, then what is the other angle? The other angle should be, total is 180, so this angle is 90 degrees minus A, correct? So if this angle is A, the other angle is 90 degrees minus A, correct? Let's say the triangle is ABC. So in this particular triangle, what we observe is that angle B is 90 minus angle A. And here also we see the same thing, that the angle B is 90 minus 10. 90 minus 10 is 80, 90 minus 20 is 70, 90 minus 45 is 45. So what we observe here is that the angles which I have taken, that is the set of angle A and B which you are talking about, are, when you add them up, you get 90 degrees. And that is when you get the same ratio. Now, can you pause the video and explain this answer? Let's look into this explanation also. So let us say that the sides are, now opposite to vertex A, we always refer this side to A, opposite to B small b, opposite to C small c. Now what is sine of A? Let us write down what is sine of A equals to, and what is cos of B equals to. Now B is this side, A is this side. Sine is opposite over hypotenuse, right? Sine is opposite over hypotenuse. Now opposite to A is side A. This is A over hypotenuse is C. For cosine of B, which is adjacent over hypotenuse, what do we see? Adjacent side is A, right? So we get A and hypotenuse is C. Do you get the same answer? Yes, you do, right? So you'll always get the same answer provided A plus B is 90 degrees, right? So if A plus B is 90 degrees, then sine A equals to cos B. You could also say that sine A is equals to cos of 90 minus A. Since in this triangle, 90 degrees minus A. So you can have so many combinations. So whenever you need to find set of angles which could give you same value for sine A equals to cos B, then you could always look for angles in a right triangle. So we call them as co-functions. So they are actually correlated angles. You can sometimes call them as correlated angles. So in a right triangle, the other two angles form this kind of a combination, correct? You could also say cos of A is equals to sine of 90 minus A. We are at present talking about angles within 90 degrees. We say angle A is greater than or equal to 0 and is less than or equals to 90 degrees, right? So we are considering those cases at present only. So you'll observe that in a triangle, if you look from one side, then the opposite becomes adjacent from the other side, and that is the reason why sine of A is cos of 90 minus A. For a 45-degree angle, both sides are equal, so they will be equal always, correct? So that is how you can look into this relation. I hope you understand and appreciate what are these correlated angles and what is so special about them. So the most special thing about them is that sine of one angle is equal to cosine of the other angle. I hope that helps. Thank you and all the best.